Now let us see this case. So we can say there are two discs, okay, and this is of radius r, and this disk is of radius r by 2. Now I have to find the center of mass of this system. I know the center of mass is m1 x1 plus m2 x2 by m1 plus m2. So this is the center of mass of this disk, and this is the center of mass of this small disk. So I'm assuming this point as 0 comma 0. Okay, in the axis system I'm assuming this point as 0 comma 0, and from this I have to take the points. Now I have written m1 x1 plus m2 x2 by m1 plus m2 equals to a1 x1 plus a2 x2 by a1 plus a2. So why I have written like that? Because so when you take mass, it is the product of density into volume, and here as it is disk, it is the product of density into area. So we have to talk about areal density here. So m will be equals to density into area, and if you take the density, in both the cases density is same because both are of same material, so we can take it like that until and as it is specifically specified. So both are of same density. So in this formula, how do we get a1 into d1? So again you get here a2 into d2, again you here you get a1 d1 a2 d2. So density are same everywhere, so d1 will be equal to d2 and d will be cancelled. Okay, d can be taken out here and d can be taken out here also, so d and d goes, and the remaining left is a1 x1 plus a2 x2 by a1 plus a2. Okay, I hope you got this trick. Okay, now let us see how we are finding. So what is the area of bigger disk? Yes, actually x1 is 0, so this point, so this point is 0, so total term can be taken as 0. And what about area of the second disk? So it is pi r square, pi r square. And what about the radius? It is r by 2, so pi into r by 2 whole square, it is r square by 4. What about x2? So you have to consider the distance of this point from this point. So already there is a length r, and plus there is a length r by 2. So r plus r by 2 is 3r by 2 by a1 plus a2. What is a1? This is area 1. So here you should not take 0 because previously there was x was involved, so the whole term went be 0. Now it is not like that. Area of the largest sphere is pi r square and the area of smaller sphere is pi r square by 4. So now simplify this, 3 by 10r. So that is the position of center of mass. Okay. Yes, now let us have a look into another question. So there is a shape. Okay, this is E. Okay, there is a shape, it is given like that, and we have to find the center of mass of the system. Okay, now we are assuming, so please see the whole length, this length is given 3 meter and this length is 5 meter, where each is 1 meter. This is 1 meter, this is 1 meter, this is 1 meter, this is 1 meter, this is 1 meter. Similarly, this point, so this is 1 meter and this is 2 meters. Okay, I hope you can get it clearly. Now, so to make the question easy, so we are dividing it into 4 parts. So first is this part, and second one is this whole big part, and third is this part, and fourth is this part. Okay, now I am finding the mass and geometric center of each parts. Okay, so please see that. Yes, and as I told here, we can again go for a1 x1 plus a2 x2 and so on. Okay, similarly a1 y1 plus a2 y2, because here you can take the density. Now what is the area of first part? Let us see each thing clearly. So the first one, if you take a1 is equals to 2 meters square. So why it is 2 meters square? Because this length is 2 and this length is 1, so 2 into 1. What is the area of second one? So this is the area, so this is the area, so this length is 5 and this length is 1, so 5 into 1. What about a3? So this is the third part, so this side 1 and this side 1, so 1 meter square. A4, so this is the area, so this length is 2 meter and this length is 1 meter, so 2 meters square. And what about the coordinates of each part? So x1, so when you take x1, so this is the first part, and x1 equals to 2. So please remember one thing, this is the geometric center of each part. Okay, so for this small part the geometric center is lying here, okay, at this center. So x1 will be, what is the value of x1? So this is already 1 centimeter and this whole length is 2 centimeters, so it will be in the middle. So at this point it will be, and from the coordinate system if we assume this as 0, then from this to this 1 and from this to this 2. So I'm writing x1 equals to 2. What about y1? So this is from this side, you please see, already there are 4 meters and this is whole 5 meter, and at the 5th meter in the half position there is center of mass, so it is 4 plus zero point 0.5, that is 4.5 centimeter. Okay, now let us see for x2. So this is the second part. So for the center of mass will be lying somewhere here. Okay, so this is a geometrical figure, so we can easily say it. So this length is 1 meter. So what will be the half of this length? It is 0.5. What about y coordinate? This whole length is 5 centimeter. Then this part, this length will be half of that, that is 2.5. What about the third part? So third part is like in this part is the third part. So this is 1 centimeter and the center of mass will be at the center, so it will be 1.5. And what about y3? So this is 1 and this is 2 centimeter plus half of that, so 2.5 centimeter. So similarly x4, so this is the fourth part again, so it is similar to the top case. X will be 2 and y will be just half of this 0.5. Now how do we find xcm and ycm? So a1 x1 plus a2 x2, and that is what we have to use. What about a1 2? What about x1 2? So 2 2s are 4. What about a2 5 into 0.5? So 2.5. a3 into x3, 1 into 1.5. a4 into x4, 2 into 2. So by what is the total area? 5 plus 2 plus 1 plus 2. So that is 10. That is how we find the xcm and ycm. Okay. Yes, please see it once again clearly. You can get it very easily. Let us have a look at this question. So yes, there is a rod of length L and the given value lambda, that is mass per unit length, that is equals to A plus Bx. Now we have to find the position of center of mass. So the formula which we use is integral dm dot x by integral dm. So this is what we use. So for using this formula, we should know the value of dm. So that is the mass of a small length. Okay, the small mass. Okay. For that, we are assuming a small part dx at a length at a distance x from the rigid end. Okay, and the mass of that part is dm. So please try to understand, the length of this small part is dx. Okay, this small part is dx and the mass of that small part is dm, and it is at the distance of x from the rigid end. Okay, so please get it clearly. Now we have to find dm. So dm equals to the mass of that part equals to, so generally how do we find the mass? So if I'm giving you the stick, okay, if I'm giving you this stick and I'm saying mass of each part, mass of each meter, okay, each meter is suppose let us take 2 grams or something. Then if I'm asking you to find the mass of 5 parts, okay, 5 parts, then you multiply 5 into 2 and you give me the answer. So similarly we are using here also dm, the mass of this part is equals to mass per unit length, so there is some value and this length has some value, so the total mass will be mass per unit length into the value of this length, so that will give you the value of dm, and I have the value of mass per unit length, that is a plus bx dot, the length of this part is dx, so that is dx. So this is the value of dm and this is what you are going to substitute in the formula. So integral dmx by integral dm, And yes, the limits are important. So we are finding it from 0 to the length L. Okay. So 0 to L, limits 0 to L, a plus bx dx, and this x is there. So please see that x I have written it here by integral dm. So this value you have to write it here. Now you please multiply this x to this, okay, to the this part. So it will be ax plus bx square into dx. Okay, I have written this x the in the different side. That is what I made. So I'm multiplying this x inside. So ax plus bx square into dx by this is same a plus bx into dx. So the limits from 0 to L. Now how do we integrate? So ax. So integral of x, that is x square by 2, and if it is x square it is x cube by 3, and similarly here x is x square by 2 and the constants are written as it is, and as it is L and 0, how do we substitute the upper limits and lower limits? So it is L minus 0, anyway the 0 term goes, so it is instead of x I am writing L. So even if you substitute, you are going to get the same answer. If you substitute both L and 0, you are going to get the same answer as this. Now you please simplify this and the answer, and this is the value of center of mass. So this, please see this question. This is a different model. From a disk of radius r, a part of circular disk r by 2 is removed. Find the center of mass of remaining part. So here there is a big disk of radius capital R, and inside this big disk, to the side, to the right, to the side from radius, a disk of radius r by 2 is removed. I have to find the center of mass of remaining part. So please see, this is very easy. Previously, we have used the formula a1x1 plus a2x2 by a1 plus a2. Now we are removing the a2. So I am using minus a1x1 minus a2x2 by a1 minus a2. Okay. So now this is the point 0 comma 0. So anyway, a1 will be pi r square and x1 will be 0. So the whole term goes to be 0. a2 is pi into r by 2 whole square, so it is pi r square by 4 into x2. x2 is this distance from 0 to this point, so that is r by 2 into r by 2 by a1 minus a2, pi into capital R square minus what about small area, it is pi r square by 4. So this is the answer, and you can see the minus symbol here. So the minus symbol represent the center of mass shifts towards the left side, because after the removing you can see some part like this. Okay, so here where the mass is lying, so here there is no mass, so it actually shifts towards the left side like this. So minus r by 6 is the answer.